Hey business, 20 students, this is Mr. Doucette, and as I promised, I am going to cover some of the problems and an explanation for chapter 11 on compound interest. Compound interest is fascinating in every way. It's because it's interest on your interest, and it's really the way in which your money can really make you money. In simple interest, you just took the principal and then you got interest on it. And so if you did, for instance, you borrowed some money or you invested some money, a better way to put it, in a simple interest type account, you would earn the same amount of interest every year on the principal amount that you invested. So for instance, in your book on page 352, it says if you have $1,000 and you invested at 10% interest at the end of year one, you'd have $1,100. At the end of year five, you would have $1,500. So basically you're going to earn $100 a year on your original principal amount. And at the end of 30 years, you'd only have $4,000 off of your original $1,000 by going with just simple interest. Well, compound interest, because it's interest on your interest. So after year one, you now have $1,100. That extra $100 is interest. You're now going to earn interest on that as well. So it's interest upon interest. And so it accumulates very quickly. And so the example in your book is in year one, you invest $1,000 at 10%. You still only have $1,100 at the end of the first year. However, at the end of the fifth year, instead of having $1,500, you have $1,600. And at the end of 10 years, instead of having $2,000, you have $2,593. And at the end of 20 years, instead of having $3,000, you have $6,727. And at the end of 30 years, instead of having $4,000 that you get under simple interest, you have $17,449 because of compound interest. That's interest upon your interest. And so that's what makes it so powerful. So your book kind of covers figuring out compound interest two different ways. One, kind of longhand manually, which you can't do on some of the longer problems unless you get into algebra, which we're not going to get into. And some of the terms that are longer years, you can do a couple of years manually, but after that it gets too difficult. Or you're going to use tables. And in the book there are two tables, your compound interest table and then your present value table. And I'll explain present value later. But these tables make it a lot easier. You just have to figure out the terms of your loan and the interest rate that you should be charging. And then you find the table factor and you multiply the principal by that table factor, and it gives you your mature compound value at the end of that particular investment period. So what I'm going to do is work through both of these kinds of problems. First, I'm going to give you the longhand version of doing it. And this is found on page 344. 11-1, try it exercise number 1. Gail Parker invests $10,000 at 6% interest, 06, semi-annually. That means twice a year. So I'm just going to do 1/2 for the year instead of doing a one. Do 1/2 for the year, or you could do 6/12 either way. And that's going to give you the interest for year number 1. So if you do the math on that, it's going to come out to $300. Now, what you do in compound interest that's not year 1, by the way, that's period 1. Every year, since it's semi-annually, happens twice. So year 1, this would be year 1, 1, and then we do year 1, 2. And then that would be 10,300 times 0.06 times 1/2. And that comes out to $309. So at the end of year 1, that's all year 1, you would have $609 of interest. So I'm going to add that, $10,609, again, multiplied by the interest rate by 1/2 equals, and that's going to be this will be year, wish I had more room, year 2-1. Sorry, it's really cramped in here. Anyway, that would be your interest for year 2. So $10,609 times 0.06 times 0.5 equals, so another $318 for a year, and that's 27 cents. Can't get it. And you're going to add that to yours, so 10,000, so it's going to be plus 10,609. Going to be, sorry, we added 10,609, 10,609 plus 318 27. So you have $10,927.27 times 0.06 times 1/2 equals, and this will be year 2-2. So you're going to add that interest times 0.06 times 0.5 equals 10,009 times 0.06 times 5 equals. Okay, I'm making a mistake in my calculator. It's another $327.82. So that's going to be added to the 10,927.27 equals, now you have a new balance of 11,255.09 times. Anyway, you're going to do this, since there's 3 years, you're going to do it 6 times. So 1, 2, 3, 4, 5, 6. I have one more to go. Might as well finish. I was not going to finish, but times times 0.06 times 0.5 equals 337.65. So I'm going to add that to 11,255.09, and that comes out to 11,592.74 times one last time. So 11,592.74 times 0.06 times 0.5 equals another $347.78. And I'm going to add that to the $11,592.74 loan, and it comes out to $11,940.52. So that is your maturity value for a compounded interest loan of $10,000 at 6% interest, compounded semi-annually for 3 years. All right, so that is the answer, and that does match with the book in the answer section. Let me check, because if it doesn't, I'm going to be upset. Yep, 10,940.52. All right, so that's the long way of doing compound interest, and there is a couple of problems that you have to do that. I don't think it's compounded semi-annually, so you only need to do 3 rows. I did 6, that was kind of a lot. But now we move into using the table. And the tables are pretty simple. There's table 11.1, and then there's table 11.2. And basically what you're going to do here is you're trying to figure out how many periods of compounding is going to happen. So in most cases, compound interest will happen, every month. It can even happen daily, and there's a different formula for that for the daily chart. But in most cases, it's going to be done in a certain number of periods. So it's either going to be compounded monthly, it's going to be compounded annually, or it's going to be compounded daily. But it's going to be broken into different periods. So every time it compounds, that's when you would take the compound interest. And interest rates are always figured out by the year. So if it's 8% compounded semi-annually, then you divide that by 2 because there's 2 compounding periods. If it's compounded quarterly, then that's 4. So you divide the 8% by 4, and you would be 2% 4 times over the year. That's kind of how it works on the tables. So just to show you how it works, it's fairly simple. I'm going to go to example 2 on page 347, tried exercise number 2. It says Jenny Cheo invested $20,000. So I'm going to write it down. At 6% interest, semi-annually, so it's going to be divided by 2 for 8 years. Okay, so if it's 8 years, so 8 years means it's going to be twice a year. That means it's going to be 16 periods of compound interest, and 6% is going to be twice divided by 2, so that's going to be 3%. So every time it compounds, each time per year, twice a year, it's going to be 3% interest. So if I go to the chart that is given, 11.1, chart 11.1, and I go down to 16 periods. So I go to 16 periods, and then I go across to 3% interest. It gives me a table factor of 1.60471. All right. So that's my table factor. All I need to do is multiply 20,000 by that number. And that's going to give me my compound total, my maturity value. So 20,000 times 1.60471 equals $32,094.20. So my total maturity value is $32,094.20. My compound interest amount is my principal minus, or my compounded amount minus my initial principal investment. So it would be $12,094.20 would be my compounded interest amount, because obviously the total includes the original $20,000 that I invested. So I made a $12,000 increase or value on my investment. That's pretty good. And that's what I earned. So let me double check my answers here. That is question number 2, and the answer is $12,094.20 by using the table factor. So the table's pretty simple to use. The hard part is knowing how to convert your interest rate and your period. So just keep in mind that I'll draw it out for you one more time. Every year, sorry, I'll put it this way. So basically your interest rate is divided over a year. So if it's 4 quarters, the interest rate would be divided by 4. The periods of compounding are multiplied by whatever many times it's compounded. So, for instance, if it were 4 years, hold on, if it were a 4, let's even say more, if it was a 3-year loan and it was compounded semi-annual, that's 2 times a year. So you would multiply 3 times 2, which means it would be 6 periods. Look at that. So if it's basically, it's going to be either compounded quarterly, monthly, annually, and daily is different. So this would be, annually would be times 1, monthly would be times 12, quarterly would be times 4, and then there's semi-annual, which equals times 2. So if I have a loan that's 3 years, again, and it's compounded quarterly, it would be 3 times 4. If I have a loan that is a year and it's compounded monthly, it'd be times 12. Or if it's 2 years and compounded monthly, it would be times 12, which would be 24. So I have to divide my interest rate, but I have to multiply my periods depending on how many times it's compounded. So that's the only tricky part of it. And I'll do another one just to kind of make it clear for you. In fact, let me just do one of the, let's see if I can find one. Okay, here's one here. So here's a loan that is $36,000. Oh, never mind. That one's looking for the interest rate. I don't want to do that. I want to do the compound amount. So here we go. All right, so this one's $13,000 over 3 years, 12% interest rate, and it's compounded. It's compounded monthly. Okay, so I'm going to go to the table factor to figure this out. And here's how I do it. It's going to be 3 years at 12%. So I need to take the 3 years and I need to multiply that by 12. So that equals 36 periods, right? And then my interest rate is 12, and I need to divide that by 12 because that's how many times it's going to be done. equals 1%. So my table would be 36 periods at 1%. So if I go to my table, I don't think I have 36 periods. I don't, so I'm gonna have to show you how to do that next. So I should have picked an easier problem. Let's just change this one up a little bit for fun. So I don't have to go through all this. Because this one here, you would have to, well, we could just do it, I guess. In this case, I already deleted it. Well, we said it was 36 periods for 1% interest, 36 periods, and it's going to be $13,000 original investment. So what you need to do when you don't have enough periods on the chart is you need to divide it by 2. So what's 36 divided by 2? Divided by 2. 18. So 18 periods. So in this case, what you would do is you'd come down to 18 and you'd take 1%, 18, which would be table factor of 1.19615. And then since you have 36, you need to do another 1.19615. What you're going to do is you're going to multiply those two together. That's going to give you a new factor. So 1.19615 times 1.19615 equals 1.4307748.2. So that's the number you multiply then by the 13,000, and that gives you $18,600, and that is the compounded interest that you're going to have over that period of time. So it's 1 cent. So that's the answer. And then if you want to know, well, what's the new table factor? It's 1.43077. And in fact, in this question in your book, it asks you for what's the new table factor and what is the compound amount. So I'll do a couple more. I'll do one more regular one, and I'll do one more that requires you to do 2 periods. So here's some normal ones. $11,000 interest, 6 years, 4%, and semi-annual. So because it's semi-annual and it's 6 years, it's going to be times 2. So 6 times 2, there's going to be 12 periods. And because it's 4% interest and it's going to be twice a year, it's going to be divided by 2, which equals 2%. So I'm going to have 12 periods, 2%. That's what I go to the table for. So I go to table 11.1. Table 11.1, 12 periods, 2% interest is 1.26824, and I'll multiply that by 11,000. So I'm going to take 11,000 times 1.26824 equals $13,950.64. That is my new maturity value. If I want to know what my compound interest is, I'm going to subtract 11,000 from the 13,950. And that is how to use the compound interest table. Hopefully that helps. I'll do one more in a second. A little thing to consider: if whenever you're working out compound interest problems, if your number is lower than your original principal amount, then you know you've made a mistake. You either used the wrong chart or you made your calculations wrong. It's always going to be more when you're doing the table here. You're always going to come to your maturity value, and your total is always going to be higher than your original investment or your original amount. When you do present value, which we'll look at in a minute, it's always going to be lower than your original amount because it's what you're starting out with. So let me work out one more problem here. Excuse me. I'm going to work out one more problem that has to do with one that's not on the chart, so finding a new chart value. So here in your book, there is, so it's a $10,000 investment. It's 40 periods, so 40 years. It's annual, so it's every year. and the interest rate is 3%. Okay, so in this case, it's 40 periods. Now my chart only goes up to 25. So in that case, what I need to do on my chart is I need to just do the 20, and then I need to look at the interest rate for that. So that it's basically going to be 20 periods at 3%, which is 1.80611. And I'm going to multiply that by, again, the same amount for the other 20. And that's going to give me my new table factor. And that's what your book calls it. The new table factor, 1.80611 times 1.80611 equals 3.262033. I'm just going to let me double check the math on that. Okay, 326, so that's the answer. And then I'm going to multiply my 10,000 by that. 10,000 times 3.262033 equals $32,620.33. All kinds of bugs out here. And that is my answer for, actually, I already have the answer. It's right here. This is the check, your check-in. So it's $32,620.30. So that's the way you do it. So just keep in mind when you have something that's not on the chart, just divide it in half and then take the amount for the half a number of periods and then multiply it by itself. And then you'll have the new table back. All right. Last thing I'm going to do is move on to present value. And present value is exactly the same thing. The only difference is that you are using a chart 11.2 for all of the present value. And what present value is how much is something in the future worth today? So if I said, hey, I want to have $150,000 in the future, how much money would I need to invest today in order to have that at these rates and these terms? And so if I say I was going to buy a fleet of trucks, or I was going to buy some new equipment that cost, $200,000 in 10 years, then how much do I need to invest today so that in 10 years I will have $200,000 in the bank? And that number is always going to be lower. So you kind of start with the higher number, and you're going to end up with the lower number, because the lower number is what you would need to put in today in order to have that at the end of that loan. So really what you're looking at is the maturity value in the present value. So it's the same exact thing, except for you're just doing it backwards. So I'll work out one problem here. This is page number 356. Try it exercise number 6 under section 11.6. Count Gustav wanted to renovate his castle and Bologna in 3 years. So he wants to do it in 3 years. He's not doing it now. He estimates the cost then to be $3 million. Use table 11.2 to find out how much Count Gustav must invest now at 8% interest. Hey, Business 20 students, I got cut off there. I think my battery on my computer died right when I was in the middle of explaining how to do present value from chapter 11. And so I believe I was showing you how to calculate for a number of periods that is not on the chart. Chart 11.2 is what we use for compound interest. And in case I missed, I don't even know exactly where we ended, but I'm just going to go back through a couple of these problems. But basically, you want to use the table. So the easy way to use the table, of course, is if the periods and the interest rate are all on the table. If for some reason there's more periods on the table, more periods than are on the table, then you have to do some extra math on that. And what that kind of looks like in the present value section of the book is, I'm going to work out one of the problems here that will help us to do that. But in section 11, I did this section 11, 11.7, page 357, try it exercise number 7. I think I did this problem, but I'm going to do it again if I didn't. This one says it's an $8,500 investment at 6% interest, compounded quarterly. So that's going to be 4 times for 10 years. So I was going to show you this particular one. You have to figure out the table factor a little differently. So In this case, because it's 10 years, that means it's compounded 4 times a year. That's going to be 10 times 4, which means it's going to be compounded 40 times. And then it's also, the interest rate is also divided by how many times a year it's compounded. So that's going to be divided by 4. So that's going to come out to 1.5%. So the table factor we're going to look for is 40 at 1.5%. That's table 11.2 for present value. However, on table 11.2, it only goes to 25. So therefore, I should just go to 20 at 1.5% interest and take down the table factor, which is 0.74247. And I'm going to take that twice for each of the 20 years to make up the 40. I'm going to multiply those together. And so 0.742 0.74247 times 0.74247 equals 0.551267. So that's now my new table factor for finding the present value for this problem. Just going to multiply that by 8,500, which is the amount I'm hoping to have at the end of this. And that comes out to $4,685.72. So in order to have $8,500 in 10 years at 6% interest compounded quarterly, I'm going to have to put in $4,685 today. In 10 years, I'll have $8,500, almost double my money, which is pretty cool. So that's how you do present value. You're just using the chart. The big struggle there for most students is knowing how many periods. And of course, depending on how many times a year it's compounded, that's how many periods per year that you would do it. And then the interest rate is divided by how many times a year it's compounded. So in this case of the problem I'm looking at right here, it was 10 years at compounded quarterly, which is 4 times a year. So that was 40 periods. And it was 6% interest compounded 4 times a year. So I had to divide it by 4, which gave me a 1.5% each time it was compounded. And that's what I used to find my table factors. In this case, I had to find 2 table factors that both were the 20 period ones. And then I came up with a new table factor of 5512617. So hopefully that makes sense. And hopefully this chapter isn't too difficult for you, especially if you watch this video. I don't think that you'll find it to be very difficult at all. Have a great week, everyone. And I will look forward to next week's video. These are very challenging for me. So thanks for all your support. Have a great week.